Welcome to John Teaches Sean About His Brain, the podcast where I, Sean, embark on a journey to understand what's happening in my own head. Spoiler alert, I have no clue, but that's precisely why we're here. In each episode, I explore questions about the brain that I believe will resonate with all of us. Like, why can't I turn my brain off at 3 a.m.? Why my memory only works when it feels like it, and why my brain seems to betray me when I need it most. Listen, I'm not a scientist. I'm no expert. I'm just a guy looking to unravel the mysteries of my own mind. Fortunately, I happen to know a cognitive neuroscientist who is an expert in the brain, and I get to ask him all the questions I want. So, if you're curious, confused, or simply along for the ride, welcome. And hey, if you like what you hear, don't forget to like, follow, subscribe to the podcast, or whatever it is you do wherever you listen to podcasts. I don't know how the algorithms work. I just know that your support keeps this journey moving forward. And together, we might just discover something remarkable. This is John Teaches Sean About His Brain. Let's get started. Hi, John. It's good to see you.
Hey, Sean. Good seeing you. How are you doing?
I'm great, thank you. What is on your mind this week?
I read an interesting article. You know how if you hear a song on the radio, a certain song, it brings back really strong memories of like high school or of something that happened to you?
Yes.
And people always talk about that, about songs bringing up, memories about things. So there was an interesting article that just came out, and it's from the University of Waterloo, where they looked at songs to see the effect that songs had on people's memories, I should say, not recall, but memory. I'm getting technical. I want to forget I just said all of that to see how songs affected their memory. And what they did was they compared that they would play songs that were popular. These are college students that they're testing,
Okay.
that are participants in their study. So they would play songs from like 2015 to 2018. So it'd be when the kids are in like middle school to high school,
Right.
or maybe it's 17 to 22 or whatever,
Mm-hmm.
2017 on. Anyway, they picked a range of songs. So they would either play the song or they would read the lyrics, or how they would record the lyrics being read, like spoken instead of sang. And they would play them one of the two, and then they would have them, as they're listening, at any point that it stirs up a memory or something like that, just to hit a button, which would pause everything, and then they would write down what their memory was that drew to them.
Mm.
And songs almost immediately would bring memories. They would hit the button and start writing, but as they listened to the lyrics being read, it would take a long time. So part of the idea, I should have said that part of the idea, the reason songs create such strong memories are the lyrics are so meaningful to us. And in fact, like when we're listening to songs, an old song will come on, and like Casey will say, our kids will be around, she'll say, "Oh, you have no idea how important this song was, how much this song means." And we say that kind of jokingly, laughing to the kids. Yeah, you have no idea what this song means and how important it is because we listened to it in our high school years. So it's the idea that something about those lyrics just capture, the way they said it just captured my feeling. But it turns out, according to this research, it's not just the lyrics alone. It's not just the words that capture us. It's the music. And so their kind of conclusion around that, one of their conclusions is that music becomes like a marker, a mile marker, or a time marker that you can attach certain things to. It's processed in a different part of the brain than just understanding what the words are saying. You have music processed in another part of the brain. So that gives that additional marker or timestamp to tie things to, because the brain's always trying to associate things and tie things together. And the the tune is what is in a different part of the brain that helps tie those things in kind of as a mile marker. So I just thought that was fascinating.
Oh, well, okay. So I think you just answered this question before I asked it. But so you're saying the actual music, the tones, the beats, all that, that's processed in a different part of the brain than the
Hmm.
lyrics,
Yes.
and
The
so
melody is different. Yes.
melody. But so when we talk about like songwriters and lyrics specifically, and how much the lyrics mean. Um, Is it the combination of the melody and the lyrics, or as far as memory is concerned?
Yeah. So this article did not touch on that
Hmm.
specifically, but in my mind, it's it might be not as much of a combination as we think because I just so many songs that just have bring up so many emotions in me. I'm not even sure what the lyrics like. If you listen to Bob Dylan, like part of you don't even know what he's saying some of the time.
Yeah,
Usually,
great songwriter, horrible singer. I
yeah,
know it's a hot take here, but all the songs that either got covered of Dylan's or that he wrote and someone else sang,
uh-huh.
like objectively speaking, are much better songs than the ones that he sang.
Yeah. I mean, I kind of like his voice too, though. So
Oh,
I'm a
okay.
fan of his voice just because it is different.
Yeah.
But you're right when I mean there's no when somebody who can really sings a song, it's like wow.
Yeah.
But just
Wow.
knowing he's an artist and that he sounds like an artist instead of a singer, I kind of like that genre
Oh,
of
yeah.
like
Okay.
not folksy, but I like so it's not just that. It's I just sometimes don't understand the words, or I think the words were saying something. I find out later the words were saying something totally different than I'd thought my whole life.
Yes.
And
There's
so
a
it
lot
wasn't,
of that. There's books written that is just filled with lyrics that people get wrong.
yeah, exactly.
And that you really you sing a song and then someone hopefully in your life is like, "What'd you just say?
Yeah,
That's not the lyric to that song."
I can't remember what show I was, a series of something where a guy just was kind of by himself. I mean, there was another person there, but he started singing. He like was singing out, and they looked over at him because he was singing the lyrics, and he was obviously wrong, but he
Hmm.
was just singing it with so much passion. They're like, those are the. He's like, what? Yeah. So the argument, I know that's I love skits like that.
Yeah.
Uh, they're so realistic. But I think to me that would show that the melody is more important. Maybe both together. I think you can't. So it would be silly to say that, in my opinion, it'd be silly to say that those two really good lyrics and a really good melody together isn't doesn't create a better memory. But I don't know if it does or not. It sounds silly to say that, but I don't know.
That's what I was. I know you can't answer this because I don't know if there's even any research or if you know of the research on it. But if one of those two things plays heavier on memory, meaning it's the melody or it's the lyrics, or if it is actually the combination, and that's what I was trying to get to. Is like I'm fascinated by people who can write music, meaning like write the melody, and
Hmm.
then also write the corresponding lyrics to go with it
Hmm.
and how it just it gets to you. Like music is a really interesting thing for me because uh, I think music is not cultural, meaning like it everybody in every culture that I know of has some form of music,
Hmm.
um, and and so like music is a really powerful thing. But now you're talking about memory, and there are songs that, and even me who have I'm on record as having a horrible memory, but I'll hear a song sometimes and it evokes like a really strong response. I have a memory associated with that
Yeah.
song.
Exactly. Yes.
And so
Yeah.
I'm really interested in that. What is it that touches my memory between the lyrics, the melody, um, time of my life? I don't know.
I just said yesterday, literally yesterday, I said to Casey, and this is before I saw this article this morning. So I didn't already have it picked out. I had something else picked out, but I saw this morning and decided to talk about it because yesterday I just said to Casey, I said, if there, everybody has regrets at the end of their life. They say, oh, I wish I would have done this or that more. I said, I think that my regret is going to be that I didn't listen to more music, because
Oh,
music is so powerful, and I get so busy doing other things, and I don't know, when I turn on music or listen to music, I just yeah, I love music, all
yeah, me
different
too.
kinds, all
Me
different
too.
kinds.
I
So
would say I have a pretty eclectic taste in music.
yeah, language, when our brain decodes spoken word,
Mm.
it's in an area for this is for right-handed people, so most of the world. Left-handers, it can be a little bit different. It's this way in some left-handers, but not most of them. But language is processed in the left uh, hemisphere, kind of just above and maybe a little bit in front of the ear. And musical notes, when you uh, when you can tease apart the different musical notes, so like a melody, that's processed in the exact spot, but in the right hemisphere. So it's like music is its own language. It's like a language and language, but one is words and one is music, and
Right.
it's processing those, which also shows kind of how they're tied together and why music can be meaningful, just like language is so meaningful to us.
Yeah, and I don't want to take this too far. I was just thinking about we were just talking about the movie Close Encounters of the Third Kind. I don't know if that's an older movie,
That's an
but
old movie. Yeah.
music is the key component in that as a means of communication. And so for us to
Okay.
communicate with an alien spaceship, essentially, there's these five notes that they play, and that alone, these five notes, gave us the ability to. It's not a documentary. I was just, it just reminded me of Close Encounters of the Third Kind, but
Yeah.
and music specifically.
Yeah. That's awesome.
But
Yeah.
yeah, so changing. I don't want to lead with this, but I have to. So because it's true. But I was watching this magician who I love. I like. He's got a whole bunch of Netflix specials, uh, and and I'm watching, and he does this. I want to call it a trick. I mean, he's a magician, but whatever it is. But he sits people down at this table, and he has them put both their hands on the table and in front of them, and then he takes this little board. It's just a way to obstruct your vision of your left hand. So he puts the board like at the shoulder, and then drapes a piece of fabric over your arm. So essentially, I'm sitting here, I can see my right arm on the table, and then my on the left side, I can't see my left arm. It's obstructed.
It's
And
covered with a
then
cloth or something.
yeah, there's
Yeah.
he builds this little like wall there,
Okay.
and then covers your arm with a cloth.
Yeah. Got
So
it.
like from I'm wearing a t-shirt, I can see my t-shirt, but I can't see any of my arm.
Hmm.
And then he takes this big, comically large rubber hand. I mean, it's obviously not a human hand. It's not my hand, but he sets it on the table. So now I'm looking at my right hand and a rubber hand where my left arm would be. Is this all making sense so
Yeah. No,
far?
I can see it now. Yeah.
Okay. And then he takes, I don't think that it matters what you use, but in his case, he's using a feather, and he's touching their real hand and the rubber hand at the same time with a feather. So he's
So
kind
their
of
right hand
stroking
and their rubber hand.
the left hand and the rubber
Oh,
hand.
the one that's hidden.
So the one I can't see
Oh, okay. All
and
right.
the one that I can see, which is a rubber hand, and
Mm-hmm.
he's stroking both of those hands with a feather. And so I'm seeing the feather touching the rubber hand, and I'm feeling the feather touching my actual hand. And then at some point, he stops stroking the feather on my real hand, and he's only doing it on the rubber hand. And right there, this is where it starts. People are saying they can feel that. They can
Yeah.
feel the feather on the rubber hand.
Yeah.
And so at this point in the brain, and this is where I'm going to get to, I'm way out over my skis for bro science. I have to ask you about this, but in the brain is registering a sense of the feel based on what I'm seeing. So now we're like, it's this mixture of sight, which is a really powerful sense, reporting that I'm feeling that feather. So that'll be number one. But then I'll just get to the end of this. But then he puts a piece of ice on the real hand, and no one says they feel that. But then he'll take a lighter and put a flame like on the rubber hand, and people say, ow. So you see how now it's getting mixed up, like the rubber hand is in place of the actual hand. And then because he's a magician and he's a funny guy, he takes a hammer and smashes the rubber hand and people freak out, right? So listen, I want to just end my little presentation to you with this. I actually went online and look, and there's actual real scientific research using this rubber hand setup. And I found way more of those than I found the one magician on Netflix doing it. So, it's not only my bro science and a magician. Like there's actual scientists doing this experiment, but I've seen it replicated a whole bunch of times now. I went down this rabbit hole. So I'm saying all of that to say, can you just kind of talk to me here about, number one, how vision can literally trick my brain into feeling things that obviously are not there, and then how how this whole setup works. Once I saw it, I wanted to talk to you so bad to go, what is going on in the brain that you can trick the brain like that?
Yes, I love this. I love the concept behind it. Yeah, I've seen it multiple times, and I've read research studies on it. So I think there's two questions you're asking. I'm going to answer the first one with concepts we've already been talking about in this podcast, and then I'm going to answer the second one with research around phantom limbs, which is kind of a phantom limb is when you've had, like, if you were to have your arm amputated right below your elbow, then you still felt like you had your hand, or you still had pain in that, let's say it was your left arm, to follow the example of this magician's using. So say that the rubber hand, you put it on your left arm, so your left arm is amputated. People can still have feelings of pain, or that their fingers are twisted or whatever. They still have those really strong feelings, and that's from a limb that's not there anymore. So it's called phantom limb syndrome.
Okay,
so
I've
I'll
heard
answer
of
the
this.
second part with that. Okay, so we'll talk about that second. But the first part is kind of interesting, because we've spent a good amount of time talking about how the brain, and I said this was one of my goals of the podcast, was to get people to understand that your brain is sealed off from the world. And so in order for it to help you understand your surroundings and help you move through your world, it has to take information from the sensory systems. They'll convert that physical energy from the world into neural energy, and then your brain uses that neural energy to build an internal image of what the world is like out there. So now, in this case, when the magician started out by rubbing a feather on the rubber hand and the real hand at the same time, and all the person saw was the rubber hand, right?
Yep.
So they didn't see them rubbing a feather on their real hand, but they felt that. So now the brain is getting a signal that something is stroking my hand, and then from the haptic sensory system that processes touch, and then from the visual sensory system, it's getting the signal that something is brushing that arm right there at the same rate where my arm should be, at the same rate that they match up. What I'm feeling and seeing is the same. So your brain just builds that image of our hand as being touched with a feather. So that you have to do that first. And there's been research to show if you don't tie those two together initially, then the experiment doesn't work. If you just lay the rubber hand down and start hitting it with a hammer or doing whatever, though, people are going, that's weird. What are you doing? But if
Right.
you somehow tie them together where you're touching them at the same time or using a feather at the same time, in your brain that locks those two together. So now your brain is going, that's my arm. Even though it looks a little bit different, it's got enough evidence to say that's my arm. So then it can feel heat when you put a lighter on it. It can feel pain when you smash a hammer on it. I mean, people report, they usually jump. The ones I've seen,
Yes. They
when a
jump when
hammer
they gets
hits it,
hit.
they jump way back and their real arm comes out and everything. And then they'll sometimes rub their real hand where the rubber
Hmm.
hand was hit. And they say, yeah, I can still feel that. That hurts. So yeah, that's I love that part because it's just an example of how your brain builds an internal image of the external world and gives you the idea that it's, the realness is in how well it builds it. So there's, what's real and what isn't.
Right.
So
That
you
makes
have any
sense.
thoughts on that before I?
No, I'm just, again, listen, we've been at this for a while. I'm starting to understand how my brain works a little bit, but just, it's funny because the other part of my brain that's going, this doesn't make any sense, right? Like that I'm looking at the rubber hand and I know it's
Yeah.
not mine. I know this dude's not going to hit me with a hammer, but and it's going back to what you just said, is your point about how the brain, the power of the brain to construct what we believe is reality, and how, if you understand the brain well enough, that can be manipulated a little bit in this case, to
Yes.
go even as strong as my understanding is in this, the magician version of it. And I think it may be in another one, but he made a point of holding up the rubber arm in front of them. Like there's no, here it's right. Here's the rubber arm, and then place it down there. Like how
Hmm.
strong my
Yeah.
brain to go, no, I saw the rubber arm.
Hmm.
He showed it to me. I know that's not real, but that can be overcome with the power of the brain again saying, no, this is reality. This is what's going on based on all the things I'm taking in from the world.
Yeah. And in research, they'll even say to people, is that your real arm, do you think? And and people don't say, yeah, I think that's my, they'll go, no, that's not my real arm. I know that's not my real arm. But then you tap it and they go, oh yeah, I just felt you tap. How can you feel that when I thought you said that wasn't your real arm? So it's also the split between the on channel and back channel.
Yes.
So it's the
Yes.
back channel that's pulling in these signals and making sense of it. And remember, the on channel is just the narrator that's I should say the back channel is pulling the information in and creating the image.
Hmm.
The on channel is the narrator that tries to make sense of it.
Right.
And so the back channel is the one that's getting fooled with this.
Yeah. It,
And
like I
that's,
said, makes sense, but man.
but if you think about it, if something about you changes, like an a limb being amputated or something, if something changes, you want the brain to be flexible enough to go, okay, I've got to learn what I'm like now so I can continue to protect myself. So if all of a sudden my arm looks totally different because I got a bee sting and it swelled way up, that doesn't look the same. So I can't just rely on vision because if I get touch information, vision, by the way, is the strongest
Right.
sensory system. So vision a lot of time overrides others. But if I'm getting signals from, haptic sensations or sounds or whatever, then I've got to just put that stuff together and realize now this is my arm. Even though it looks different, that's my arm and I've got to protect it.
Right. So let's then transition into the second part is phantom limb, and we'll keep it just at an arm. Uh, there's been an amputation below the elbow.
Okay.
And so, we're going back to, I can see visually, I can see there's nothing now below my elbow.
Hmm.
And there's no haptic sensation below the elbow. So this idea of phantom limb, then what's the information that is fooling my back channel or my brain to say, you know, there's something there, and it's, or I don't even know what, let me back up. Let's just say, what are the, I guess, symptoms, or what does phantom limb pain actually mean?
Yeah, that's probably where we should start
Yeah.
because this is all from my readings. I've read about it quite a bit and I've taught about it, but I've never uh, worked with a an amputee to get firsthand knowledge of this, but there's tons of research out there about it. And my the history of it is when somebody would have their, if we're sticking to arms, their arm amputated, and this can be from, I think most amputations happen because of vascular issues, so like diabetes, or because of cancer. And I think those are like 90% or something, or 85% of the amputees are health related.
Okay.
And then there's also the accidents where you get your arm caught in machinery or you're in a bad car wreck or something like that. But I think originally some of the original research on this was in war zones and where soldiers would be injured. And so, think back, Civil War, World War One, where somebody has a problem that the doctors out in the field say, we've got to saw your leg or your arm off. And so they'll saw the arm off because otherwise gangrene and all the infections are going to die from it. So it's like, we've got to stop that in order to save you. You've got to give up part of your arm.
Right.
And then people would say later, the pain is so, I can't live with the pain from that. And so the thought was, well, it wasn't, we didn't make a clean cut, so to speak. So let's amputate a little bit more, maybe 3 inches
Further.
more, and try to get a really clean cut. And so they would get that, and the person's still in pain. They're going, either you're going to have to live with it, or there's enough room to try one more surgery. And so, there's a difference between residual limb pain from the surgery itself and phantom limb pain. Those are two different things. So the surgery site can cause pain, but this is, and there's, neuromas form, which is scar tissue that builds up that has all these nerve endings that were cut off kind of clumped together. And so that can cause pain where you do need to do something surgically to help with that scar tissue pain. But what most people were complaining about was phantom pain. And I think it's something like, 3 out of 4 or maybe 4 out of 5 amputees experience phantom limb pain.
Okay.
And it's usually a few months after the surgery. And what it is again, it's the feeling that my missing limb is in pain of some kind. And I think the most common is that missing limb is twisted and gnarled, and I can't straighten it out. It's like if you took your hand, put your fingers together, and really twisted your wrist and just held it like that, pretty soon that starts to get really sore and then uncomfortable, and then it starts to be painful. And so they feel like their hand is just cramped up in that way for, it's just cramped that way, and they can't straighten it out. And that's where phantom pain comes from.
Okay, so like if we're sticking with the hand, it feels like my fingers are like just, I don't know, you said gnarled. I guess that's and then my wrist is, turned in. But if that's the feeling, that's what I wanted to get to, is if that's the feeling, there's nothing there for me to see, and there's nothing there for me to, from a haptic sense, to feel. So what message is being sent to my brain?
Yeah. How do you solve that? Like, there's nothing there. So the person's crazy, right? They have to be crazy. It's like, I know that's not the right term, but I'm saying that's what you think is like, there's no arm there, dude. What are you saying that you're in pain? There's no arm. You're crazy. Like, just get over it type of thing. But it turns out that the brain is actually processing information as if it's there. And so and by the way, phantom pain occurs more often in legs than arms, but it's still prevalent in arms. But let's just say that you're saying that I have this pain here. What is it? Well, pain is experienced in the brain is the first thing. The signal goes up, so it's our brain's interpretation, and usually it's a way to help us remove ourselves from the pain, get away from it so that we can survive. So that painful sense is, I got to move, I got to do something different. Like if I can't leave my hand over the fire because that's not good. So I immediately get that sensation to pull it back.
Right.
now you're getting those signals about something that's not there. So what's happening in the brain? And back in the early to mid 1900s, there were several neurosurgeons who would do surgery on the brain. And so I feel like I have to explain this to explain the phantom pain. But before neurosurgeons started experimenting with the brain, there would be somebody would have some type of a deficit, like they couldn't talk, let's say. And so when they died, the physician would some physician, not every physician, but researchers and scientists would look at the brain and say, oh, here's this area here that's damaged. They would make a note of it. And then somebody else would say, hey, this person that couldn't speak just passed away. And they would say, well, let's look at the brain, or you look at the brain and see what area is damaged. And they would say, oh, that's the same area. So that must be an area of the brain that relates to our ability to be able to speak. And then that was kind of a way to start understanding different areas of the brain. And then neurosurgeons came along, and they would say a person would have like an internal brain bleed or stroke or something. And so they would go in for surgery and say, well, it's down. So we talked a little bit about brain names. So it's a left hemisphere. It's medial, meaning it's kind of on the middle, the inside. Middle. So I'm just going to cut through and get to it and do some stuff and then pull out. And then when they finish the surgery and the person recovers, they say, how was the surgery? How are you feeling? And the person just sits there and looks at them. They're like, how are you feeling? They can't talk. And so maybe they can write a note. So they haven't lost language, but they've lost the ability to speak. And it turns out they cut through that area that had already been shown to be responsible for speech. And they're going, oh, we need to start being more careful when we're doing surgeries with the brain. Yeah. And so the brain doesn't have any pain sensors. And so what they started doing is saying we really need patients awake when we're doing brain surgery so that we know which area of the brain, because when you open a brain, it's not labeled with little dotted lines, and some are colored blue and some are colored red, and this says this is for speaking, and this, it's just it's an organ there, it's tissue. So they kind of, there's, similarities and resemblances, but everybody's brain is just a little bit different. Like there's landmarks that you can tell every brain has the similar landmark, but then one person's ability to speak might be located just slightly at a different area than the next person's, even though it looks fairly similar. So you want to be able to see where it is that you're getting ready to, where their speech is centered, so you don't cut through that. Right. So since there's no pain receptors in there, people can stay awake. So they'll put a topical anesthetic on the skin, and they can just cut the skin off, like scalp you, and then your bone doesn't have any pain sensors. And so they'll just take the top off so they can see the brain and get to the brain. And then once you remove a piece of the skull, the brain is encased in this tissue that's what's called the meninges. There's like 3 different layers of it that kind of protect the brain. And that's, you've heard of meningitis. It's an infection of the meninges, that protective area over the brain. Oh. So those are the meninges. Oh. There's the outside layer. I'm getting really, since you're looking excited, you're encouraging me. The outside layer is a really tough material. It's almost like fiberglass. It's really fiber, and it's hard to cut through. And it's named the dura mater, which means in, I think, Latin, one tough mother. So that's the toughest part. And then inside that is the arachnoid layer, which is like spider webs where all the fluid is flowing through. And then the last layer that overlays the brain is the pia mater, which is the tiny mother or the fragile mother. And that's just a fragile thing. You can just tear through that with your fingers, versus the dura mater, you need a sharp object. So those protect your brain inside your skull. So you get into that, and now I'm getting ready to cut into the brain, but I got to know where, and the person doesn't feel any of that. They would feel you cutting through the scalp, but you put a topographical stuff on there. So they're laying there awake, and they're feeling all this going on in their head. And then some of the surgeons in the early to mid 1900s, they would take little electrical probes. And since the brain is electrical in nature, it sends electrical signals back and forth. A small electrical probe will disrupt, if you probe a part of the brain, it disrupts the brain's function. Whatever it's doing there, all of a sudden it's flooded with the electrical signals, so it releases its neurotransmitters and things. It's not functioning as normal. So they'll have a person start counting down from 10 to 1 backwards, and they'll be touching their brain all around that speech area to try to find it. The person will go 10, 9, 8. They can't say anything. You're going, oh, I just hit the speech area. And you let off of it in a minute, they'll go 7, 6, 5. So you go, okay, that area, we can't cut through that because that'll affect their speech. And by the way, neurosurgeons still do that. So, yeah, and one of the kind of most well-known and famous neurosurgeons in the mid-1900s, 1940s and 50s was William Penfield. And he did a lot of the brain mapping using the electrical probe to try to look at different areas. He also found when he would touch certain areas, he would just say, he would touch an area. And say, so when he was going to do a surgery and the person's awake anyway, he would spend a little bit of time exploring, and he would touch an area and say, tell me what you think, feel, what happens. And he would touch it and they go, oh man, I just got a really strong smell of my grandmother's apple pie. And if he would kind of mark it and go do something else, he would come back to it and they go, oh, I just smell my grandmother's pie again. So, where memories are located, it would just release neurotransmitters around that area. And one of the things that he did is over where the frontal lobe and the parietal lobe, the frontal and the occipital lobe separate. There's a deep groove. And on the front side of that is, did I say frontal and parietal, right? It's frontal and parietal lobes, which is the front and the top. So the divider between them, just in front of that divider is the motor cortex, and that's what sends signals. So that's the motor cortex in the frontal lobe, and then right behind. So it's like a band of tissue. It's got your brain has ridges. So it's the ridge right before that really deep groove. So the ridge right before the deep groove is your motor cortex. The ridge right behind the deep groove is your somatosensory cortex. And that's what processes haptic sensation. When somebody touches you, like the feather on the hand was processed first at that somatosensory cortex, that little strip band right on the top of your head. So he would go through and touch on the motor cortex to see what moved, and touch on the somatosensory cortex to say, for people to tell them what they felt. So he'd touch one area and say, oh, I just felt like something poked my toe or twisted my toe. Then he would go to the next, oh, that just hit my knee. So he was able to map out the somatosensory cortex and found out everybody's is really, really similar. And he drew a map of what body parts, kind of how the body parts are laid out in the somatosensory cortex. And there was and some areas had more, like the areas of the hand took up a larger area than like the back, because you don't have many receptors in your back, but you have a lot in your hand because your hand's important when you're picking up things or touching things.
That makes sense.
You need to be able to discriminate really fine detail in your back. You don't need to be able to discriminate fine detail. You just need to know if something's touching it or on you or whatever. So people built a model of the human body as if it was representative of the somatosensory cortex, and it's called the homunculus. And it's this person with a little tiny back and legs, but really big hands and like really big lips with eyes. Everything's proportionate to how it's mapped out in the brain. So it's this funny looking creature because that's how the sensory system is mapped out, your body's sensory system. So anyway, I told all that to say, now we know where the map is. So now if you imagine that you have sensations coming from your hand into your spinal cord that go up to this part of your somatosensory area that represents your hand. So when you snap your fingers, that represents that. If your fingers get twisted and bent, that's going, those neurons are firing. They're like, oh, our hand is twisted and bent, and they're responding to that. Now you get your arm amputated, and those neurons that were in that area that was responding to your hand and fingers, they basically have just lost their input. And so now one of the rules of the brain of cells is that they have to be making connections and sending and receiving signals, or they die. The brain cells do. And it's called apoptosis, which is like programmed cell death. It's like a cell suicide. If I'm not getting signals, I'm dying and I'm out of the way. And so that's kind of encourages neurons to reach out with their dendrites and their axons to try to make connections. And so what happens when there's an amputation, and this was discovered by Ramachandran, a neuroscientist in the 1980s and 1990s. He came up with this idea that they're reaching over into their neighboring areas and making connections so that they can still survive.
Stay alive.
Yeah. And that was his idea. So he was saying, oh, they're reaching over to something else. So maybe their signal now, they don't know what this signal they're getting from this other area, which it turns out for a hand, they're right next to the face. So they're connecting to the face, and then a signal that the face sends to them, they don't know what to do with it. So they're probably sending painful signals like, hey, something's got to change. I don't recognize this. This is painful, because they don't know what to do with that signal. And so now they're saying I'm in pain. And so what he did is he took, and I, with students in my classroom, I would always say Ramachandran is like the MacGyver of neuroscience.
Oh, I don't want to know
it. Great way to describe it.
I think it is too.
Remember, MacGyver would take a paper clip and a piece of gum, and a bomb's getting ready to go off, he would fix it, or whatever. He would just, whatever's around, I'll just fix it.
Yeah.
But my students started going, who? I was like, I'm getting old. You guys don't know who MacGyver
that
is?
hurts.
And they're like, no. And I said, go ask your parents. They'll tell you. And then it got worse, though, Sean. A few years later, I still used the term because I loved it. And I would tell them, this is a cultural moment for you to go look up MacGyver, because that's so important to our culture, I guess. I don't know what I was thinking, but I would say, go look it up. And a few years later, I said, I consider this person, because he would use like a paper clip and a piece of gum to solve a problem. I consider him the MacGyver of neuroscience. And one of the students said, you mean MacGruber? I was like,
oh,
yeah, that was the spoon.
Oh, we are old. Yeah, that's an SNL skit that became a movie, but yeah, no.
So Ramachandran was much more serious than MacGruber. What he did is he would have people close their eyes, and he would take a Q-tip and just stroke different parts of their face. And he would do it a few times, tell me what you feel, and they would go, you're touching my face, and all of a sudden they go, oh, that felt like you just touched my thumb on my left hand, and they don't have a left hand because of being amputated. And he would go, oh, okay. So he would stroke different parts of their face. And then once they started tying the face to the hand, they would tell and he found out that it's something weird, like your thumb coming over and your fingers down the side of your face. Anyway, he mapped it out and every amputee basically who had their left arm or their right arm amputated had that face map. And so then he so that was really cool. But then he is the first one to come up with this trick that the magician was using, because he thought, okay, if it's mapped in this way and it's just a wiring issue, then we need to start rewiring and using neuroplasticity to rewire this. So how am I going to do that? And so just on a whim, he got a shoebox that a pair of tennis shoes came in, and he laid it long ways in front of the person, kind of to their side, where they're like, if their left arm was amputated, he laid it on the left side long ways, and he had cut a hole out of the end of it so they could put the stub of their arm just in the hole. Now it looked like, if you look down, it looks like your arm is in the box. But
it's like the trick I started this with.
Yeah.
Except without the hammer.
Yes, but there is no arm in the box, but it looks like that.
Right.
And then he taped to the not the inside to the outside of the box, but on the inside, like a mirror so that he'd have them lay their right hand on the table and the mirror reflected their right hand. So it looked like their right and left hand were both on the table.
Okay.
So he used a mirror and a shoebox. And then he started doing the same thing. He would have them, he would say, I want you to move your right thumb and your left thumb at the same time. Do it together. And then as they were doing that, they could see the mirror because it was, and he said, I'll move your four fingers together. And they would do that. And then your right hand. And he would have them do things together where both hands were doing it together. And then they got the visual confirmation that their left and right hand were both doing the same thing at the same time. And it wasn't very long, the pain started to leave because now I can see my fingers aren't twisted and gnarled and bent backwards. I can see they're laying out and I can move my fingers. So I know they're not twisted. And that signal was sent to the brain and it started rewiring. And he came up with mirror therapy where you do that a certain amount of time each day over a few weeks and people's phantom pain largely went away.
Oh, wow.
Which I think is fascinating. He did it with a shoebox and a mirror and a Q-tip, on the face.
Yeah. But and so again, knowing a little bit about what you've described neuroplasticity is you just do a little bit every day over a certain amount of time, and then your brain has been trained, so to speak, that phantom pain goes away.
Yeah, it'll rewire itself. To now, it's still connecting with the face, but it's understanding those signals as being something different, not being painful signals.
Not pain.
Mm-hmm.
And then again, going back, if I imagine if you stop doing that, I'm calling it training. I don't know what you want to call it, but if you stop doing the training, would the phantom pain come back and then you have to do it again?
Yeah, from my memory of it, if you just had a few sessions, it would come back fairly quickly, but usually not as bad. If you did it for a longer amount of time, then you could stop for a longer period of time. But it was kind of like a use it when you need it. If it started to come back, you just pull out the shoebox and mirror. And medical device companies can't really sell shoebox and mirrors and make any money, so they've made other devices and things, but shoebox and mirrors still work. But there's other devices and probably that work a little bit better. I know there's like the TENS machine, the electric stimulation, and some other things. So there's other ways that people will look at it. But well, here's another way. There was a person I was reading about a while back, but he was a pianist and he was in his 60s and had cancer and had to have his hand amputated. One of his hands, I think it was his right hand, was amputated. And he had severe cramping in his fingers of the amputated hand, phantom limb. And it was even when we're talking about music at the beginning, this is tying that back in.
Oh, you're going to tie it together?
When he would hear a piano piece being played, the right hand part especially would just cause severe cramping in his hand when he would hear it. And so one of the things they did with him, and also like CBT, cognitive behavioral therapy, like where you talk about, you give people, you train people how to keep better control over their thoughts and what they're thinking. Okay. So how you think can affect what you perceive, and also, change your thought pattern, and that's going to help you. And that can get rid of some of the triggers that can set it off and things like that. So he was doing CBT, but they also started a virtual reality training that had in the screen, he could put his hand on his wrist on a keyboard thing that wasn't connected to anything, but both hands, and kind of move it up and down and play with his left hand. And in virtual reality, he was seeing fingers move and the piano being played. So it's kind of like the mirror theory, but it's with VR. And over time, that VR treatment, they did like the scans, like fMRI and things. It remapped his motor and sensory cortices to dramatically reduce his phantom limb pain, almost get rid of it completely. So that's VR, which is another tool now that Ramachandran didn't have.
Yeah. I wonder if through VR, um, that there somehow, when I look down, my hand is there
Mm-hmm.
in VR. Similar, like you said, similar to the shoebox with the mirror,
Mm-hmm.
but just doing that a couple of times,
That
once a day for a couple minutes.
that
Uh,
helps.
yeah.
Hang on just a second. You can keep. I can hear you, so ask your question. I'm going to reach for something on my bookshelf that's not
Oh
behind me,
yeah.
in
No,
front of me. Go ahead.
go ahead. Go ahead. No, it wasn't much. It wasn't as much of a question as much as it was just thinking about technology. Going from a shoebox with a mirror to train the brain is now. You bring up VR and bring up. I watch too many movies, but now I'm starting to think about all the different ways to train the brain with technology to reduce
Well,
phantom limb or whatever the application would be.
and I was just thinking of another example. I used to tell students a woman had from foot amputated for diabetes, and she felt like it was twisted around behind, kind of bent backwards, and frozen down in solid ice. And so it was the freezing part that was most painful for her. She felt like her foot was frozen. And so part of what they did is had her. I think they put a like a mask, the mask that covers your, like a sleeping mask. Put that over her
Mm-hmm.
face to try to block out the light. And they put her foot that she still had in warm water and had her imagine her other foot was in the warm water with her. And just through her imagination, it started relieving some of that frozen feeling. Even though it didn't get rid of it completely, it helped get rid of some of that. So even like
Yeah.
imagination. So and VR is just uh, it's like a souped up version of imagination, one that people, because now you can really see what's in your world. And when I'm saying see, you know what I mean. It's like you're seeing imaginary things, but it's in VR. And so yeah, all of that it's really, they're really powerful tools. I picked
Yeah.
up, the reason I had to stop. I picked up this book, Phantoms in the Brain.
Phantom in
It's
the
by
brain. Phantoms in the
yeah,
brain.
Phantoms in the Brain. Yeah, by V.S. Ramachandran and Sandra
Oh,
Blakesley. He
okay.
wrote this book. It says Probing the Mysteries of the Human Mind. It is a great book. It's older. It is published 1999, so that's an older book, but it still has great stories in there of some of his research and his clinical research and things. And he
Yeah.
again is the one that he talks about phantom limbs in that book, obviously, but more than just that, talks about visual stuff too. But yeah, the phantom limb is so fascinating, and it really, I think that the thing that makes it fascinating is for the two reasons you brought up. One, it gives a great example of how our brain uses the information it has to build this image in our mind of what our world's like. And we're relying on that image that's built. And it's not always accurate. I mean, a magician with a feather and a rubber hand can change your world
Trick it.
drastically. So it's not always as accurate as we think it is, and our mental image isn't always as accurate as we think it is. But then the second part, it just demonstrates the power of neuroplasticity and how your brain can rewire itself and adapt to fit in to this new situation. I don't have this hand, so but I feel like there's pain there because I don't know what this signal is. And now I've got a mirror in a shoebox, or I've got these VR goggles, and so I'm going to even rewire more to understand it better and adapt better. It's just a great example of kind of the power of our brain, what it can do.
Yeah. Yeah. And well, I mean, it's a great example of the power of the brain, but then also how I can be manipulated. Darn it!
Yeah.
If you understand it, you can trick my brain.
I used to tell students in my class, and this was so I taught different classes. I would teach like intro to psych, uh, cognitive psych, sensation and perception, memory, and learning and memory. Um, and then I taught classes like one place it was called biopsych, biological psychology. So biopsych and physiopsych. And those classes, I would always tell students, this is, no matter what you do in life, this may be one of your most important classes you ever take from a social standpoint, because what you learn in this class, you can use at any cocktail party you gather at or anywhere to insert yourself into any conversation. Because if you take the psychology part about our behavior and how it works, then you can talk about all kinds of things related around behavior. So, and then if you add the physiology behind it and the biology, so you're looking at the brain and how the brain works and how these different areas in the brain function, you've got that part to add to it. And what topic do you want to talk about? If you're talking about sports, we've already talked about how I think, oh, you know what? We were talking about sports at one point and about how hitters see the baseball. I think I remember you saying, I just had a thought.
Yeah.
I very rarely have
we were
these
talking about
thoughts.
vision. Yeah.
Yes. The people will say, I can see the seams on the baseball. And you were like, how's that possible? I don't know why this hasn't occurred to me before. It's possible because their brain is creating, you know how we talk about the brain is always behind, like a tenth of a second behind. So it has to predict what's coming next to keep us up in real time. So it's making predictions all the time. Well, that ball coming through the air is just a prediction. So if it's predicting, probably over time, the brain has learned if my predictions freeze it at different points so I can see a seam, that will give me an advantage to hitting it. I bet they really do feel like they're seeing a seam, because I believe them. They say they see the seam, but there's literally no way you can see the seam when the rotation, unless a knuckleball you can, but a regular ball, there's no way you can see this. But it's there. It's not the baseball that's entering the brain. It's the physical energy from light reflecting off the baseball that enters the brain, and the brain creates the image. So maybe it's creating an image in snapshots to help them, give them an advantage. That's a wild way to think about it. But see, drop that at a cocktail party and see how dumb it is. You'll be. I didn't tell the students this, but pretty soon people aren't going to be inviting you to cocktail parties probably. But you can still, like, if you're talking about politics, now you've got the psychology side where you can talk about psychopaths or psychopathologies or egomania and different things. And I'm not talking about any specific politician right now. I'm just saying in general. And
sure. Yeah. Okay. Just in general.
Just in general. And if you're talking about what are some other topics? I mean, just about any topic, you can bring something from psychology or biology into the discussion, especially neurology. And so, I used to tell students that just you can be a part of any conversation at any cocktail party now if you really pay attention in this class and learn.
Yeah, it's a good not marketing, but it's a good way to get people interested, I guess.
So you aren't buying that then? You think it's just a sales speech? So, like, I taught statistics, and I would always have students ask me, am I going to use this? And I would say, well, hopefully you'll use it for critical thinking when you're reading studies and stuff, but probably not. I saw
okay.
I saw on Twitter somebody said, I remember asking my math teacher in algebra, am I ever going to use this again in life? And his response was, well, you won't. So it's like, that's kind of bad.
That's cold-blooded.
That's really cold, isn't it? So, yeah. So some students won't use it, but some could.
Yeah, sure. As a way to be to insert yourself in conversations and then ensure you never get invited to those parties again.
Exactly. You don't want to be. That might be why I'm not invited. I never thought about that either till now. You're opening a lot of new lines of thought. Because I usually just stand at parties and throw out brain facts.
Well, I think that would make you popular. I mean, look at this podcast. This thing is this is all you just talking about facts about the brain.
And it's so popular
we're getting
right now.
Well, we're getting new listeners every week. That's not a joke.
Yeah.
So thank you as always for all of that, because I started my section of this podcast off with a magic trick and you were able to explain using an phantom limb and actual science, how these things work. So as always, I just appreciate your time, your information, and you're helping me through this learning about my brain.
Yeah, and if I could, I probably would
Please.
trade my science knowledge for a set of good magical tricks, because those will get you into the party even faster than science. I
That
love
gets you
magic.
invited back to the party, I
That gets you
think.
invited back.
That's
Yeah,
what,
you might not insert yourself
absolutely.
into every discussion, but you get invited back. I love magic, watching magic tricks. I love it. So that's a great place to start.
Me too. And and I know that there's probably more uh, like magicians out there, and that they do different kinds of tricks. I don't know all of but this guy, Justin Willman, is his name. He's got a whole bunch of stuff on Netflix. One of them's called Magic for Humans. It's just, if you like magicians, you should go and watch him. I love that dude, and he's funny, and he's really good at what he does. So,
I'll have to check it
speaking
out.
of really good at what he does, thank you, John, for that. Teaching me about my brain yet again. And for everybody else, if you're still with us, don't forget to like, subscribe, and favorite, and spread the word. I'm no BS. On Friday, I was at a dinner, and someone who I don't talk to that often, who I really like, but came up and just said, "Hey, I heard you're doing a podcast, and that I might like it. What's it about?" And yeah. So, this little part might be working, where I'm encouraging everybody to tell a friend, tell a coworker, tell a loved one if you think they could use this information. And hopefully, and don't forget our socials, both the show. We're on Blue Sky, we're on TikTok, but John's socials, and that's Prof. John. Is that?
Yeah,
I
but
ask
it's
you every
usually
week.
find it at Brain Dude, Brain
At
underscore
Brain
Dude,
Dude.
Brain Dude.
Okay.
I'm
Well,
Prof.
John's
John at Brain Dude.
TikTok. I'm a big fan of. I look at it daily. That's not a joke. And so if you like the show, if you like John's smooth vocals, you'll love his TikTok page. So until next week, thank you, John. Thank you, everybody, and we'll see you then.